Yo guys, welcome back to another one. So here we are, question 9 of the June 2009 paper. So we're given a figure, this figure 2. And here, this is in the shape of a sector, or a 3D version of a sector, otherwise known as a prism-based sector or sector-based prism. That's probably the more official term. And this sector-based prism, we're given the usual information. So we know we're working in radians, we've got radius r, we're given a height of the prism, which is h. So figure 2 shows a closed box used by a shop for packing pieces of cake. Alright, yum. Better hook me up. The box is a right prism. The box is a right prism of height h. We know this. The cross section is the sector of a circle, good. And the sector has radius r centimeters and angle 1 radian. We know straight off the bat that the volume is 300. Okay, cool. Show that the surface area of the box s centimeters squared is given by this. Right, okay, so this is where the challenge comes. So what I would personally do is firstly work out the surface area, and because they're asking for volume, this implies that we need to write down a volume equation. So the surface area straight off the bat we know is going to be the area of the sector plus the area of each of the sides here. So what do we have? So this area of the sector here, we know that should be half r squared theta, which is 1. So just half r squared times 1 plus, and we got a rectangle here, don't we? So we got height and the r, so we got a rectangle here with a height and the radius, and we got two of them here and here, plus, so we got two lots of HRs. We also have this side, so the curved surface area part. Okay, so this might look like a rectangle, but indeed, it's actually something else. Yes, so the curved surface area part is literally just the arc length times the height. So the arc length we know is going to be, so we'll put plus, arc length is r theta, which is just 1, so r times 1 times the height. So it's r height. So I'll put the length here, which is r theta, which is in this case just r. We also have another sector. It's actually the bottom one. So we did the first one, now we need the second one. So it'll be two lots of these. So therefore we're going to have two lots of this, which is just r squared. Plus adding these up, we're going to have 3 RH. Okay, not bad. Now the volume. Okay, so we need to find the expression to remove the h here. So you know that the volume is 300. What is the volume of this shape? Well, all we need to know is work out the area of the sector, which we know, and then multiply by the height. So the area of the sector is just simply half r squared, which is r squared. So r squared times the height is r squared half r squared height. Okay, not too bad. And we know that the volume is 300, so we're going to have 300 equals half r squared h. Boom. Now just replace h of this and we can h the subject. We've got h equals, so multiplying by 2 first, we can get 600, and then dividing it by r squared, we can get 600 over r squared. Substituting back into this final surface equation, we're going to have r squared plus 3r times 600 over r squared. And voila, we can see right now that we're going to get r squared plus, 3 times 600, 1800, and r cancels with 1r at the bottom, so we're left with 1r left. Okay, good, not bad. This was a tricky shape, but we had it in the end. Okay, so quick recap. This part is the curved surface area, the rectangular base twice, and this is the curved surface part, and there's two lots, so I should put extra half r squared. Okay, cool, not bad. So let's move on to part B, yeah, and otherwise you can check out the other ones. Okay, part B, C, and D. Now we're given the S equation, which we previously proved. Here we have to use calculus, in other words, differentiate, to find the value of R, for which S is stationary. So yeah, pretty much do what you do. So use differentiation on this equation and pretty much set the derivative to 0 and solve for R. That's pretty much what it implies by being stationary. So let's have a go. So for part B, let's rewrite this equation. S therefore should equal S equals R squared. So keep it in the correct form. plus 18 times r to the power minus 1, because that's a plus. So finding ds over, get my pen on properly, dr, we should get, so differentiating r squared will give us 2r. Taking the derivative of this part, we drop the power, so we get minus 1800 r to the negative 2. And because we need to assume this is stationary, we set this equation to 0 and so for r. So let's put this on the other side. Therefore, we're going to have 2r equals 1800 r minus 2, or we can reverse this and call this 1800 over r squared, so return it to its actual form. Multiply both sides by r squared, we're going to get 2r cubed equals 1800. Dividing by 2, r cubed equals 900. And finding the cube root of this value will give us, let me get my calculator. And that gives us about 9.65. So let's just say 9.65 centimeters. So curly bracket. Good. So this is the value of r. So let's try part C. So prove that this value r gives a minimum value of s. So to prove it gives a minimum value s, we just need to differentiate again, put the value r in, and show that the second derivative is greater than 0. This proves it's a minimum. Okay, so taking the second derivative, what do we get? So here we get d squared s over dr squared equals, so differentiating this term, we should just get 2 plus, dropping minus 2 gives us a plus, 2 times 1800 is 3600, r to the negative 3. So yeah, if you put the value of r in, so I mean, let's just do it for convenience, say 2 plus 3600 over this term cube, so r cube, so it'll be over 900, because remember, r cube times this will give us just 900. Cancelling this down, 36 over 9 is 4, so it'll be 2 plus 4, which is 6. And yes, it's bigger than 0, therefore the value of r here is therefore a minimum, so it'll give us a minimum value of the surface area. Correct. Now let's move on to part D. So therefore, find to the nearest centimeter squared this minimum value s. So yeah, all you do is pop in the value of r into this equation to get the minimum value s. So I can just do it here. So you can call it the s minimum. So the absolute minimum is going to be, what was the value of r? Root 300, root 9, cube root of 900. So it's just going to be all of that really. So you're going to have, I'll use the exact form by the way. Cube root of 900 squared plus 1800 over cube root of 900. Throw this in the calculator, and here we should get 280 centimeter squared. And that's it, guys. Hope this helps. Let me know if you need any other further instructions. Otherwise, good luck with your revision, and make sure you smash C2. Ciao.